Hi there. In this video, we're going to be going over the quotient rule. For this, you're going to need to know two things. Like all the others so far, this method of writing exponentials and what exponentials are, so repeated multiplying. So in this case, this is multiplying a x times, so 1a, 2a, 3a, all the way up to xa's, or to actually use numbers, if we said a to the fifth, that would be 1a, 2a, 3a, and then 3 dots just to mimic what I did there, and 5a's. So you could use this to do any number. So if this were, say, 20, this would be 1, 2, 3, 3 dots, and then 20. So the 3 dots would represent everything between 3 and 20. You don't need to put these numbers down here. This is just to keep track of how many there are for this video. And it's actually going to come in handy for the proving of the other two things. And then this, which was a previous video, which is negative exponents. And if you have something to a negative exponent, you can rewrite it as 1 over the same thing, just without the negative. I do prove it in that other video, so there should be a link in the description to it. Anyway, on to these guys. So this one is actually the quotient rule. Over here is, it looks similar, so I am going to go over it, but it's not the quotient rule, it's a little bit easier. So we can rewrite this as 1x, 2x, dot, dot, dot. You don't need to make it go out to there, you can do as many as you want. You should have at least 2, though, just so you know it's incrementing by 2, because you could technically have 2x, 4x, maybe not, I don't know. Anyway, back to the important part. All the way up to ax's. So that's all over 1y, 2y, dot, 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 ay. So you can actually rewrite this then as 1x over 1y times 2x's over 2y's, and keep going till you get to ax over ay. So as you see, there's actually the same number of x over y, so you can actually rewrite it again. I'm going to write it down here, so that's I'm going to use parentheses, x over y, 2 x over y, dot, 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 finally, a x over y. Put that a little silly. But now this looks exactly like the general case where it's 1 thing, 2 thing, dot, 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 a things. So that can then be rewritten as just this here. So I do hope that made sense. Be sure to comment in the comment section if it does not. And I'll try and remake the video to make it make sense. Or at least that part. Probably the whole video, though. On to the big boy. Quotient rule. So this is a to the x over a to the y. So y and x need to be, well, y and x can be different numbers, but the a's have to be the same, where it's the opposite here. X and y can be different numbers, and then the a's have to be the same for this to work. That is something I should have mentioned. So we're going to start it in the same way. I'm going to start all the way over here so we have lots of room. So 1a, 2a, dot, 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 xa's all over 1a, 2a, dot, 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 ya. Now, there are this many a's up here and this many y's down, or a's down here. Excuse me. This many a's up here, this many a's down here. So they start canceling, where the first a's will cancel, the second a's will cancel. We'll keep going Now, this can go in three different directions. If there are more a's up here, so if x is bigger than y, then that means we'll run out of a's down here and we'll have whatever's left, or x minus y. To show that, we'll say the top is a to the 5 over a to the 3. And that's 1a, 2a. I'm going to write them all just so I can cross them all out. 3, 4, 5. Then all this is over 1, 2, 3. So now they start canceling out. First ones, second ones, third ones. This leaves 2, which is 5 minus 3. So as you can see, we're taking away the bottom ones from the top. So the order matters here. In the product rule, the order does not matter. Now, what if it's flipped? Well, let's go a little bit easier before that. We'll go with if they're equal. So if x and y are the same, well, then we just keep crossing out. And if they're equal, then they just all cross out. So it becomes 1. That is if x and y are equal. I'm going to sum this all up in the end, so don't worry. So the last case, and the more difficult case, because it uses the negative exponent rule, or property, I'm not sure which it would be, is if y is bigger than x, so there's more a's down here than up here. So I'll use different numbers. So we'll say a squared over a to the 4th equals a. I'm going to go ahead and not write the numbers anymore because I think you get it. You can count. There's 2, so 2 goes to 2 over 1, 2, 3, 4. So they cancel out. You cancel out. You cancel out. So now there's nothing up top to cancel out anymore. Well, that means it's a times a down here. So that means 1, because the cancel out doesn't become 0, it just becomes 1. And then AA, that's 2 a's. Or, of course, another way of writing 2 a's is a squared. Now, if you look, this does actually hold true with this up here, because as shown down below, this can be written as a to the negative 2, and negative 2 is 2 minus 4. So in any case, it does work, and I didn't actually explicitly say it, but then when they're the same, that's x minus y. If they're both the same, then that equals 0, and a to the 0 power is 1, or well, anything to the 0 power is 1, actually. That's something that's used in different maths. So a to the 0, anything to the 0 power is 1. So to sum it all up, I'm going to leave this up here and write, and this needs space here, so a to the x over a to the y. If x is greater than y, then it's the easiest, or maybe the other ones, maybe equal is the easiest case, but then it just stays as a normal exponent. Then it's ax minus y. If x equals y, then it is a to the 0, which equals 1. Doesn't look like a minus. There we are. And there. If x is less than y, then it becomes, here, make it look a little nicer. Then a to some negative number, then x minus y will be negative. So you can actually write it as 1 over a to whatever that is. So we'll say x minus y equals z, or well, minus z. X minus y equals negative z. We know it'll be negative because x is less than y and we're taking y away from x. So negative z, that means this can be 1 over a to the z. So there's the quotient rule. I will be going over this and the product rule again when I go through fractional exponents, which is going to be a whole other video. I'm going to want to show that the product and quotient rule hold true for even fractional exponents as well. So, hopefully, this answers any question you might have had. If you have any other questions, comment down below. I'll try and answer them. Maybe I'll remake the video to more efficiently explain, because I know I might not be the best. I will see you in the next video.